All right, this part of the video, this part of the notes, we're going to talk about how to find the derivative of a parametric function. So we kind of need to talk about the definition of a smooth curve. Basically, we have a smooth curve if x of t and y of t are continuous on the closed interval, differentiable on the open interval, and the derivative of each one of them with respect to t are not ever zero at the same time. Okay, that's the definition of a smooth curve. Not super important, but we use it in the rest of this. So it says if a smooth curve C is given by the equation in parametric form, so x is defined to be a function of t, y is defined to be a function of t, then the slope of the smooth curve, basically the derivative of the tangent at a point, the derivative is dy over dx. That is going to be equal to the derivative of y with respect to t divided by the derivative of x with respect to t. And another way to write that would be y prime of t over x prime of t. As long as x prime of t is not zero. The bottom can't be zero, it'd be undefined. So to find the derivative in parametric form, find the derivative of the y and divide it by the derivative of the x. It's pretty straightforward. We'll come back to the horizontal and vertical tangent lines here in a sec. All right, it says given this parametric equation where x is defined to be that, y is defined to be that, find dy dx. Okay, I know dy dx is equal to the derivative of y with respect to t over the derivative of x with respect to t. Or another way to write it would be y prime. You don't have to write both of these. I'm going to write it one way. I'll probably write it this way. Okay, off to the side, I'm going to find out what the derivative of y is and what the derivative of x is, and then I'll plug it in. So I'm going to find x prime first. It's easier. The derivative of x would just be 1/2 t to the negative 1/2, which is equal to 1/2 times 1 over t to the 1/2. Y, another way to write y would be distribute that 1/4. So 1/4 t squared minus 1, and y prime, the derivative of that, would be 1/2 t. So dy over dx is equal to the derivative of the y over the derivative of the x. Oops. And since I've already done those off to the side, where'd my pen go? I get this. Now to simplify, I would just cancel out the 1/2. This would be t over 1 over t to the 1/2, which is t times t to the 1/2, which would be what, t to the 3 over 2? So the slope of the tangent line, it depends on when you are taking the derivative of the tangent line. So for different values of t, I would get different slopes of tangent lines. But whatever it is, it's going to be whatever the t number is to the power of 3 over 2. So we're going to talk about what all that means as we dig a little deeper. All right, given this parametric equation, find the equation of the tangent line when t is equal to pi over 2. All right, so they love these tangent line equations. The equation of a tangent line is y is equal to m x minus x1 plus y1. The same thing we've been doing since the first unit. All right, so m is dy dx. And I'm going to evaluate it when time is pi over 2. All right, so the derivative of y, the derivative of cosine, oh geez, what is that? Derivative of cosine is negative sine, t. The derivative of x would be 2e to the 2t. Plug in pi, whoops, I'm not going to say equal. So dy over dx when t is equal to pi over 2 is negative sine of pi over 2 over 2e to the, what, pi? Okay, negative sine of pi over 2 is equal to negative 1, sine of pi, yeah, over 2e to the pi. So that's the slope. So my tangent line is y is equal to negative 1 over t e to the pi, x minus x1. All right, what is the x value when time is pi over 2? The x value when time is pi over 2, plug in pi over 2, so it's e to the 2 pi over 2, so it's e to the pi. So x minus e to the power of pi plus y1. Y when t is pi over 2 is equal to cosine of pi over 2, which is 0. So I'm going to say plus 0. That plus 0 is not necessary, but I want you to know where it came from. All right, that would be the slope of the tangent line. All right, what's next? All right, find an equation of the tangent line to the curve when t is 1. This would be a good one to pause, try this one on your own, and then unpause and see if you got it right. Because what we just did, but it's on your own. Equation of the tangent line. So I got to find the derivative. So dy over dx is equal to the derivative of y with respect to time over the derivative of x with respect to time. Okay, and I want to find that evaluated when time is 1. So that'd be 2 over 6 times 1. So it's going to be y is equal to 1/3 x minus x1. Okay, x of 1. Find the x value when time is 1. I've circled too much, I can't see. So plug in 1 squared times 3 is 3. Find the y at 1, so that's 2, so it'd be plus 2. That would be the slope of the tangent line when time is 1. So this whole idea about parametrics, it's kind of with respect to time. So when time is 1, that's what the tangent line would be. All right, find all the points on the curve when the tangent line is vertical. All right, so a vertical tangent line has slope undefined. dy over dx is equal to dy with respect to time over dx with respect to time. So undefined slope has denominator 0. But it can't simultaneously be 0 on top. So what I have to do now is find the derivative, find when the derivative of x is equal to 0. And as long as it's not all the derivative of y is not also 0, then that's where I get undefined slope. If I had a horizontal tangent line, horizontal tangent lines are when the slope is 0. So dy dx would be slope 0 when dy over dt was equal to 0, but dx dt is not. All right, so that was that other part of that box up there that I didn't read earlier. All right, so I got to solve, when is dx dt equal to 0? Well, what is dx dt? Dx dt, so x prime of t is equal to 6t. So when t is 0, the x part, the derivative is 0. Y prime of t is always 2, so it's not going to be 2 there. So when is 0. Find all the points on the curve at which the tangent line is vertical. I haven't done that yet. All I've done is find out what time value, when t is 0, the tangent line is vertical. But it says find the points on the curve, so that's one extra step. I've got to find when is x of 0, or what is x of 0? X of 0 is 0, and y of 0 is also 0. Okay, so it's all a bunch of zeros. It's not super helpful, but what I did is I plugged them in up here. So when time is 0, x of 0 and y of 0, I get the point 0, 0. So that's the point where the tangent line is vertical. Now, if I solve this out and instead of time t equals 0, I got time t equals 1, I would plug in 1 and I would say, okay, that's going to be 3, 2. That's where the tangent line would be vertical. A little bit different here, though. All right. last question. What's this one about? I haven't looked at this one, so it's probably going to go terribly. All right, the plane curve represented by the parametric equations x of t is that, y of t is that, crosses itself at 0, 4, as shown in the graph on the right, and thus has two tangent lines. Find the equation of these two tangent lines. So when time is what? Has two tangent lines at 0, 4, I guess. So I guess we need to find the tangent lines when this is happening and when this is happening. I'm guessing those are the two tangent lines. Crosses itself at the point 0, 4 as shown in the graph and thus has two tangent lines. Okay, so it's wanting you to find the tangent lines there, I guess. There's two tangent lines, one at that one, and then the other one is tangent there. So I got to find the equation of those two lines. So let's find out when that happens, or the tangent lines. So it'd be, what do we need to do first? Let's find x prime of t. The derivative will be at 3t squared minus 4. Y prime of t is equal to 2t. So the derivative, dy over dx, is equal to 2t over 3t squared minus 4. Okay, I've got to find the points, or when this graph hits 0, 2. So I can find the tangent line. I need this point. I need this as a slope, right? But when is the point right there the first time? And when is the point right there the next time? So that's going to be kind of harder part. So at the point 0, 4, I want to find out, okay, so if x is 0, what is the t number? When y is 4, what is the t number? All right, so if I solve this one on the left, this would be, what? I would factor out a t, get t squared minus 4. This would be t plus 2, t minus 2. So when t is 0, I've got x number is 0. When t is negative 2, I've got an x number of 0. And when t is equal to 2, I've got an x number of 0. So when time is 0, maybe it's right there, or maybe it's right here. I'm not sure. But I can kind of see there's 3 points where I get x is 0. This point right here, but it probably happens twice, right? Because it goes here, the x number is 0, then here, x number is 0, then here again, x number is 0 again. So that's why there's 3 time values where the x value is 0. So if I solve for t in the y part, this is t is equal to plus or minus 2. So I get the y number is 4 when time t equals 2 and time t equals negative 2. So notice when time is 0, that must be this one. When time is negative 2, it's right here. When time t equals 2, it's right there again, because that's where those overlap. When time is 2, the x number is 0, the y number is 4. When time is negative 2, the x number is 0, the y number is 4. So those are going to be that's going to be the 2 time numbers. So I get, okay, I've got to write, I need room. Okay, I'm going to erase all this. I've got to remember when time is 2 and negative 2. I want the equation of the tangent line. So when time is equal to negative 2, I'm guessing the tangent line is that one. So I want to write the equation of that tangent line. So it's y is equal to m x minus x1 plus y1 when time t is equal to negative 2. So it's y is equal to, plug in negative 2 here. See, negative 4, negative 2 squared is what, 4, 12, 8. So it'd be negative 1/2 x minus, okay, what's the x number there? X of -2. -2 cube is -8. -2 times, so what would be +8 is 0. Oh, that's a duh. -0 plus 4, right? Y of -2 is 4, plugging it in. And we just solved that backwards, right? All right, so that's the equation of that tangent line. The equation of the green tangent line is going to be that one. So that's going to be y is equal to mx minus x1 plus y1 when t is equal to 2. So that's going to be y is equal to, plug in 2 over here. So it'll be what, 4 over 8, so positive. And then it crosses the point 0, 4, so x plus 0 or minus 0 plus 4. So there's the two equations of your tangent lines whenever those lines cross each other, which is, I think the question could be worded a little bit better. These two tangent lines of where it crosses itself. All right, that's it for this video. Hopefully it made a little bit of sense, and thank you for watching. If you have questions, ask me next time I see you in class. Bye.